idea. Hello everyone. In this session of prime time, we will talk about. I will discuss two concepts that are a bit advanced, and it would suit you well if you get yourself some experience working in prime time before studying this unit. So this unit talks about a concept called what if analysis, under which there is a set of command and there is a set of methodology that we can use in prime time to analyze that what will happen if we will this analysis, these set of commands help us in getting the fixes that have to be applied for setup and hold time. Second is I will talk about attributes. Attributes is a very powerful feature in prime time. So prime time, as you're aware, supports tickle language. So attributes actually help. They enforce the tickle language interface, reinforce it, and using attributes we can write very powerful procedures to get almost any kind of data that we want out of the design. Right. So I'll first discuss briefly about what do we need to check before fixing timing. So the regular flow is that once you are done with synthesis, the netlist will go to the post layout stage, to the layout stage where it will go through various steps, placement, clock tree synthesis, routing, and so on. And at the end of all the backend exercises, all the backend steps, what you will get as an ST engineer. So I am talking from the perspective of an ST engineer, a person who is now this engineer can also work in backend, can also work in the front end design. But I'll focus on the STA part. So I'm assuming that maybe either you yourself or somebody else is giving you the post layout data. Post layout data is netlist plus step. Now in the industry, many times it may happen that the backend tool used for post layout, that is for placement and routing, plus is different than, it's not the Synopsys tool. It can be any other company. This tool can be Magma, this tool can be Tech, this tool can be Cadence Encounter, anything else, or it can be Synopsys IPC. So these backend tools are geared towards implementing the design from the netlist stage. So the input to them is netlist, the output is again the post layout netlist and the parasitic data. But these tools are not geared for sign off. By sign off I mean checking that you are meeting your timing constraints in every corner and every node that is part of the specification. So prime time or goal time, for example, or your STA tool will be the sign off tool. So all the checking ultimately will have to be done in this tool. So it may happen that the backend tool is not seeing timing violations, but you are seeing timing violations in prime time. It happens like that. This problem is called the correlation issue between your STA tool and the backend tool. Plus prime time's timing engine is much more conservative. It lets you do so many things to make sure that you are on the conservative side when it comes to timing constraints. So all the timing reports that you will see will be in the prime time. You will make sure that all setup and hold timings, all recovery removal, min pulse, take all DRC are meeting in prime time. That is your sign off code. Now, so after the routing is done, after you get the parasitic database, so the backend any backend tool will try and fix most of the violations. But even after the first round of it, you will be left with few hundred or even few thousand violations. And now there are tools. People have written set of scripts. So every industry, each company in the industry will have its own set of scripts or its own set of tools, maybe internal, maybe external. Maybe they will purchase a tool from media vendor. So they will have a set of tools which will write out timing ECO, which will generate timing ECO based on the prime time and the STA tool results. And these timing ECOs will be again applied in backend, and a new version of the database will be prepared for timing analysis. So this is an iterative analysis. Uh, Obviously, solving all these timing violations manually is not possible. So there will always be some tool or some setup script that will do the job. But in the end, you might be left with few parts which you will have to fix manually and analyze those reports in time. So before even going to the timing EQ fixes, whether few thousand parts are left or few hundred parts are left, you have to make sure that the clock network is good to begin with. If the clock network is not good, your timing does not make sense. Why? Because if you have clock skew issues, if you have clock latency issues, then the violation that you are seeing will not be real. First, the clock network has to be fixed. You must make sure that clock relationships are well defined. The clock skew is not high, is within limits. The clock divider logic, for example, should not be part of the clock. We have just noted down some important things. This is not a complete exhaustive list, obviously. So all such cases can create issues for you. For example, if the clock divider logic is part of the clock tree and is balanced, it will have a large latency and it will result into a lot of violations. So we have to make sure that clock network is good to begin with. And how do we do that? We recheck our constraints. We use the report clock timing command. We do a good pre-layout STA and so on. Secondly, we should check all the constraints. If the design is indeed in the desired mode, you have to set some. Probably you will have to set some place analysis to put the design in functional mode. Or if you are doing so, you will have separate set of constraints for functional mode, for scan shift, for scan capture, for memory based, and so on. So for each and every mode, you will have a separate set of constraints. Then, before even going to analyze setup and hold timing, you should solve most of the DRC violations. Why? Because any DRC violation means that timing calculation is not possible for a particular path. Now, let's say if there is a DRC violation on a particular cell, it would mean that any setup or hold violation through that cell could not be relied upon, because that DRC violation has to be fixed first. So, plus more important are the DRC violations. So that you can start fixing your setup and hold timing without solving a DRC violation. But first priority is DRC violation on again clock network. If there are DRC problem on clock network cells, you have to solve them first, because any such fixes will again change your clock skew and latency and will have a greater effect on timing. So first idea is to make sure that your constraints are 100% correct. Okay, yes, you might be missing a few exceptions, but small things are okay to have, but not the big things like clock relationships, clock definitions, and so on. Clocks are single most important factor in timing analysis. Right? So you should make sure that all your clocks are of correct frequency, have proper relationships defined, and then it comes to constraints. So many times it may happen that during the fixing process, you will come to know from the design analysis or something like that the path that you are fixing might be false. So having one or two paths like that, it's all right, but having a bunch of paths which are false and which you are trying to fix will damage your design. So first and foremost, spend a lot of time on your constraints. Now, let's say now you are left with some violations, setup and hold both. So I'll list down the steps that you can take to solve how can you solve the setup violation if you are doing stuff manually. Obviously, scripts or the EA tools will take care of that. So what the scripts or what any automated ECO engine would do is it will take all the reports, all the modes. It will ask for the input will be the reports for all the modes and for all the panels. It needs to know reports or sessions, whatever. It needs to know what the violation looks like in different panels, and does the path has enough margin to fit setup or hold. So, but let's say if you are left with few paths that are not solving, that you cannot solve by, or that the software is not able to solve. It happens all the time. So there are few paths left which you have to fix manually. And how do you do that? So let's say if you are working on a setup fix, on a path that is violating setup. First priority is always fixing the data path. What is the setup path? Setup path is a max delay problem. What means is that path delay is more than the maximum permissible delay. So what do? You try to reduce the path delay. Now the path delay, total path delay comprises of the data path delay plus the launch clock network delay. First priority is always to speed up the data path. So you should look out for slower cells and replace them with the faster variants. So an example is that you can have a slower cell which is of higher VT, which has a high VT, and if you have a library which has high VT, standard VT and low VT, for example, you can choose to replace the cell by its SVT variant, and the cell will become faster. Or choose a higher drive. Let's say you have an X1 drive of buffer which is giving you high delay. You can choose to swap it out with a X4 delay, X4 drive strength buffer. This will improve your part delay, and you might meet the timing. So again, so one thing to know about this is that some swappings can be would be footprint compatible in the sense that you take the same area, like SVT to SVT swap is usually same area, but when you swap from X1 to X4, the area will increase because the X4 buffer is of a larger area. So again, so the timing that you, so this is the analysis that you can do within PT itself, but the real results will only come when these ECUs are implemented in backend and new parasitic generated. So whatever analysis I am talking about, it's at best it's an estimation. Although most of the times it will work as it is. You won't have, so if prime time shows that the path, the delay has improved, in majority of the cases the delay will improve when the actual network comes up. Second, the cell driving the capture pin, for example, let's say you have a registry violation, setup violation, and these capture flops data pin on which there is a setup violation. If it has a bad transition, then it might be a problem, because bad transition means, even because the setup check of data depends on the transition of the data pin. If you have a bad transition in data pin, even the setup check constraints will increase. So it is you can again upsize the driver or make the driver a bit stronger or faster, so that the transition and the capture pin is good. It will help into two aspects. It will help to reduce the delay for that particular element, plus it will make the transition faster, which would in turn make the setup constraints smaller. The whole constraint will also become smaller, because the setup and hold constraints both are dependent on the clock transition plus the constraint in transition to the data pin. Second, this technique is slightly more advanced. You will understand this with some experience maybe. Let's say a buffer is driving, a buffer has a maximum drive strength in the data path, and it is driving, let's say, 50 or 20 nets. So now you cannot upsize this because it is at a maximum drive strength. So upsizing is, when I say upsizing, it means that a buffer should be replaced only by a buffer. It cannot be replaced by some other element, because you have to maintain logical equivalency. So upsizing means the logic function remains same, the drive or the VT type thing. So here, let's say you have it's driving a 20 nets, this particular buffer, and it is at its maximum drive strength. You don't have more than drive strength more than this available in the lab. So what do you do? And it has more delay because it is driving 20 nets. Backend, something backend can do, load splitting. You can do load splitting. You can recommend the backend engineer to do load splitting. How the load splitting is done? Now this buffer will drive, let's say, so we will add more buffers, and this buffer was driving 20 earlier. Now let's say this buffer will drive 5, and among the 5 fan outs, one of the fan out will again drive 5, and so on. So you can add a buffer network there to split the load. This will help speed up the data path. So the principle here is that if there is a long net, or if there is a high fan out case like a buffer driving 20 nets, so if you add buffers at regular intervals, at some intervals, this distance depends on the technology, or the fan out number also depends on the technology, right? Your total delay would improve. Or yes, you are adding a buffer, a new buffer, but the combined delay of this buffer network, the idea is the combined delay of this buffer network would be less than, should be less than the case where a single buffer is driving 20 fan out. So this is a more advanced case, the load splitting. Second more advanced technique is called logic cloning. Logic cloning is something where you have a cell which has again multiple fan outs, and then this fan out, this let's say AND gate, it is driving let's say 2 or 3 or even 5 nets, and one of the nets is going to your critical path. to your factor clock, and now this AND gate will have more delay. So what you can do, you can create one more AND gate, a copy of it with the same logic, and you can split the load. So splitting the load and logic cloning is somewhat similar in nature, but logic cloning can involve more than one cell or more than cloning of more than one. It can involve cloning evenly flock. So it is again it's an advanced technique. It is not done easily. You have to do a lot of checking in prime time. You have to check a lot of reports before even attempting this. Third is do path-based analysis. If the number of violating paths are small, if you have let's say 5 violating paths in a particular clock group, you can do PBA on that. We saw an example in the lab, and the WNS is less. Let's say if the WNS is let's say of 50 PS, minus 50 PS, and you are hoping that it meets, you can do PBA. The longer the path with multiple input cells, probably the more advantage you will get out of PBA. Lastly, you can play with the clock skew. So we were talking about the first priority is always fixing the data path. Last priority is touching the clock network. Now, touching the clock network is not easy. You have to do a lot of checking before playing with the clock skew. So the concept is that you either delay the capture clock or make the launch clock come earlier. Whatever you do, it is going to affect. Let's say if you make the launch clock earlier, it is going to affect the setup at this launch clock. So this launch clock, if it has a critical path for setup ending at the data pin of this clock, if you are making the launch clock earlier, it will affect the setup there. If you are delaying the capture clock, it will affect the hold there. So you have to open up the session in the best case, check hold, check setup in the worst case on the launch clock, and so on. You have to do a lot of reporting before you attempt this. And this is not a simple ECO for even backend. The backend probably has to do some manual fixing here. So be careful if you are playing with the clock skew. It should be the last resort. The downside is that the faster you make the data path, it might start affecting your hold time, which is expected. So because the path delay has to be between a maximum and a minimum limit, and if you start making things faster, it will negatively affect your hold. It might. It is not necessary that it will affect hold, but depending on how the path is, what is the path length, how many start points are there, and so on. Depending on these things, it can affect negatively on hold. Now, hold timing is can on some cases it can be very easy. In some cases it can be very tricky. Majority of hold violations are because of clock skew. This is why in synthesis you do not worry about hold timing. Let's say you are considering a single clock domain. You don't have multiple clocks. You have a single clock. Pre-layout, you will not see any hold violations. Probably you will see very few hold violations, maybe on memory pins, not even on register. But when you go to backend, when you go to the post-layout database, the number of hold violations will increase by a lot, because now for all the smaller parts, for parts like shift registers, for scan, all the scan parts, for example, all such parts have virtually no combination logic between register to register. Such parts, because of the clock skew, because of the difference in the arrival timing in the clock latencies of the two clocks, the hold violations will occur. So this is again the reason why in synthesis you don't worry about the hold timing, because you are not synthesizing for hold, you are synthesizing for performance, which is setup, and there is no clock tree, so there is no clock skew in place there, so there is no need to worry. And such hold violations are easiest to fix. Simply you have to add some kind of a delay element, which is either a buffer or a delay cell. Delay cell is just a kind of a buffer with more delay. And so the first thing that should be checked before fixing any hold is that whether the first priority is adding the delay at the endpoint. So if you add the delay on the endpoint, let's say if you insert a buffer at the data pin of the violating clock, then you are made sure, if you can add, then you are made sure that even if there are multiple start points, multiple clocks driving this logic, then also the hold timing will remain fixed, because we are fixing the endpoint. Probably this will not make sense now, but when you start fixing, when you start working on some real projects, you will understand what I am saying, the significance of it. So adding a delay cell or a buffer at an endpoint is the most preferred option. Obviously, before that, you should check whether the endpoint has enough slack for setup. And how will you check it? You will load the worst case session. You will have to load the worst case session because setup is more critical there. You have to check whether there is enough slack before adding the delay cell. For example, let's say I am trying to fix a whole violation of 10 ps, 10 picosecond, and I know that a buffer of, let's say, some type, X type, will give me 10 ps, or let's say 15 ps of delay. So I know that, okay, fine, I'll add this buffer, and so this violation is in the fast corner. Let's say now you have two corners, fast corner or the best corner or the worst case corner. Now I have a violation in the worst case corner. I see that the buffer will give me 15 ps. The violation to be fixed is 10 ps. I'm good. I can add this buffer. But now I have to go and open up my worst corner session and report the setup timing to this endpoint. Now, what is the margin I am looking for? I am adding 15 ps delay in fast corner, but will this delay stay 15 ps in slow corner? No, this delay will be more in slow corner. It can be 2x, it can be 3x, depending on the cell type, depending on the technology. Now, let's say, so there is a factor by which the delay changes from best case corner to worst case corner. So let's say the best case corner is x, and depending on the technology, you can work out a gross factor. You can start doing fixes. So let's say the technology I am working on has a factor of 3. So that means the 15 ps delay in fast corner will give me 45 ps of delay in slow corner. So now in slow corner, I should be very careful and see if the path has at least 45 ps of margin. Otherwise, if I'll add the 15 ps, and if the worst case corner margin, let's say, is 20 ps, and if I wrongly assume that 15 ps is going to stay 15 ps in worst case corner, it will not work. It will start violating setup. So these are the tricky things in fixing hold. Be careful about multiple start points. If you are not able to fix the violation at the endpoint, if you are adding the buffer, so the idea to fix hold is to add delay in the path. You might add, if you are not able to add at the endpoint, you will add somewhere in middle or at the start point. That might not fix the violation, because let's say there are 5 start points and 1 endpoint, and the endpoint is violated. In that case, fixing at one start point will not help solve the violation. The other start point can also be a violator. So be careful about what you want to fix and how you want to fix by checking report timing by using the minus inverse option. That's the best option, and you use inverse option to make sure that how many start points are violating for a particular endpoint. By default, prime time reports only 1 start point per endpoint. So you have to be very careful in the usage of max path and inverse. You should understand the difference and use it. Always check setup margin in the worst corner. This is the bottom line. Don't check setup margin in the best corner. Doesn't help you. If the setup slack is, what happens now? What will happen if the setup slack is not sufficient? What can you do? What you could do is, when the setup slack will not be sufficient, usually this is the case when there are multiple start points, or there are cells with multiple start points and a single endpoint which is violating. One of the start point has long combination path, other start point has very less combination logic. So if you add the cell at the endpoint, it is going to affect even the start point with the bad combination logic. So what you could do is you can speed up the path by increasing so if you speed up that path, the hold timing, obviously the hold violation might get worse, but by a small amount, but you will get more margin on setup. Again, it's the idea here is that the delay in fast corner is less when compared to the slow corner. So here also the ratio of the delay in first corner divided by the delay in fast corner. This is better for high drive and for low VT cells. This ratio becomes, so the worse the ratio, so the ratio is delay in worst corner divided by delay in fast corner. The worse the ratio is, the more difficult is the timing fixing. Why? Because a small delay in fast corner will give you large delay in burst corner, and you cannot fix the timing. So the worse this ratio is, the more difficult it is to fix timing. The better the ratio is, the more easier it is to fix timing. So this ratio is better for low VT and standard VT cells, and not so good for high VT cells. Similarly, this ratio is bad for low drive cells. It is good for high drive cells. So by making the pass faster, you are improving this ratio, and you are giving yourself more setup margin to play with. Again, TBA can be used, but for paths with less logic depth, where the logic depth is less, usually hold paths are like that. Very rarely you will find a hold path in a single clock domain which has more than 3 or 4 logic depth. Usually it will be smaller. So the smaller the logic depth, the less margin you have in PBA. The PBA will not give you a lot of advantage. Sometimes it will not give you any advantage at all. Again, lastly, you can play with the clock skew, but be careful about it. This is the last resort, right? So prime time gives you commands, gives you tools to resolve violations by manually editing the netlist and analyzing how the changes affect timing. This is only useful later in the design cycle when you have only small violations to play with. Plus, whatever commands you apply, you can write out an ECO file from prime time, which the backend tool can read and perform the ECOs for you. Whatever commands I will be discussing now in this lab, they are used to only analyze the timing. You try and upsize the cell and see what effect does it have. You can add a buffer and see what effect does it have. It is not actually changing the netlist. You're not writing out the netlist. Then you can probably assemble these commands, whatever you applied, or automatically you can enable ECO mode in prime time. So prime time will write an ECO file for you, which the backend tool can automatically use. We will not go into a lot of operational details because it's an advanced topic again. I'm just explaining the concept here. So these set of commands are used to manually edit the netlist only temporarily in the prime time session. You don't write out the netlist, and you can analyze timing within the session itself. So this is a set of commands. The idea is the object here is buffer. The task is you can add a buffer to solve the whole problem. You can remove a buffer to solve the setup problem. You can change the drive strength of a cell. It is called size cell. You can even create a new cell. You can create a new instance of a particular cell. You can rename or remove a cell. You can create a net. You can connect a net. So these commands are similar to the netlist editing commands in DC, but the idea here is to analyze the timing. We will see some examples in the lab in the same session. So this command. Before doing a size cell, we should know that what all drive strengths are available, what cell types are similar. So when you want to replace or resize a cell, you need to know the alternative library cell that you can use. To list the library cell base names, you can use this command, get alternative list cell minus base name command. This is an example. So if we want the alternative list cells of this particular instance U1, so it gives us this complete list. So this is the list. It gives us. This is the list. Yeah, so this is the list. It tells us that there are two cells called AN2 and AN2. So this was the theory of what is analysis. We will have some examples in the lab. Now let's talk about a more very powerful feature of prime time called object attributes. I'll read it from the slide. An attribute is a string or value associated with an object in the design. What is an object in the design? An object can be anything. Port, pin, cell, instance, net. These are all objects. Clock. All these are objects. If you remember, we discussed a figure in which I showed you the different objects in the design. Now, an attribute is a string or a value associated with an object in the design that carries some information about an object. For example, the number of pins attribute attached to the object cell indicates the number of pins in the cell. How do these attributes help us? We can write now. We have some attributes defined. There are also something called user defined attributes where you can define attributes yourself, We can write programs in Tickle to get attribute information and to use it to write powerful programs. I'll write some snippets of code. I'll give you some examples also. We will try this out in the lab also. Now, report attribute here, for example, report attribute minus application, and you tell what is the object. You give it the object, and it will report the attributes for you. We will try this in the lab. So this example tells that get cells particular cell talk slash clock mark slash this clock buffer. I'm giving this particular object which is of a cell type. So every object has a type. The object this is a get cells command. The type will be a cell. I give this argument to report attributes minus application, and it will give me what all attributes are applicable available for this particular object. Example 2, let's say I want to know the count and instance name of all the SVT cells in the design. So size of collection, I've shown you the example here. So get cells minus hierarchical minus filter. This particular command, don't worry too much if you don't understand this command. You will understand some part of it obviously. Get cells which gets rid of list of cells. Hierarchical means go down the hierarchy. Complete design. Filter means that, again, this is using the attribute. Ref name is an attribute on cells which will give me the value of the reference name of the cell name, right? So if it matches SVT star, let's say assuming the library has cells which are starting with the name starts with SVT, this will give me a count of all the SVT cells. I can write a for each command, a for loop on this, and I can write out this echo get attribute my cell full name will write out the full name of this cell. It will write out the full instance path. The second get attribute is writing the ref name. It will write the ref name for this. We'll see some examples of attributes. So using attributes, the idea is attributes will help us in writing powerful prime time procedures. Usually, so even design compiler supports attributes. Some attributes may be different between design compiler and prime time in some objects because the aim of these two tools is different. But you can use it nonetheless. Now I'll move on to the lab, and we will discuss some examples. So I'll restore a session on which is on the same design that we discussed last time, Orca. I have saved the session already. I just to remind you, there are these clocks. I changed the frequency of some of the clocks to get more setup population, so we can analyze the setup population. So these are the clocks. If you remember from the last session, P clock, SDR clock, 6 clock, 6 clock, 2x. Now let me look at the what is the worst case violation in one of the clock domains. I'll do report timing minus no split minus group P clock, let's say. So let's say this is a setup violation, right? Now setup violation, I am assuming that my constraints are correct. I am assuming that my clock definition, everything is correct. I will now try and do a what if analysis on this. So I will look for cell. I'll just expand this report a bit, minus connect and minus input pins. So if I look at the data path, I'll start from the start. This is the register. Now there is a delay cell here. You know by experience. This is a delay cell DL something 2DL. The delay is 2.26. Again, there are some cells AN0 and ND2 and all that. But in this report, I can see easily that this delay cell is the one that is taking most delay. It is taking 2.26. Now, usually delay cells are not part of synthesis list. Synthesis DC, they are usually don't use. So DC will never use it. Delay cell. So this delay cell, as the name suggests, I'm just saying from experience, it was not part of the synthesis list. It was inserted during PNR, and most probably it was inserted to solve a hold timing problem. So that means there might be a hold timing path through this. Let me just verify it. I'll do report time. So I am planning to play with it. So I'll do a report timing through this particular cell, this particular pin, and I say minus delay min. Ideally, you should do this in a best corner, not the worst corner itself. If you want to see the hold margin, you should try and see it in the best corner session, not the worst case corner. You should see it in the first corner. But just for since I am showing you as an example, we'll look in the same corner. But I hope you get the concept. Now see, from the same start point, here the start point is same, count interest 0. Here the start point is same. There is one more path through this, which goes to a memory, and there is some hold thing here. Now see, 1.74 here, and now the slack is 1.55. In the fast corner, this delay will reduce by a lot. This delay will probably be 500, 600 ps, 0.5, 0.6, and there might be a violation or a small positive slack in the hold report, right? So now consider I remove this. Consider you remove this. Then there will be a hold timing violation here. So this is where you should be careful in deciding the setup and hold fixes. You should, if you are doing setup fixes, you should think about hold. If you are doing hold fixes, you should think about setup. It's not straightforward that you will speed up any cell or remove any cell or add any buffer anywhere. So we see that this delay cell is here for a reason. See that the fan out here is 5. That means this is going wherever you see fan out more than 1, there are alternate paths available. Now I should not touch this. I see that this was inserted to solve a hold problem on the memory. I see that if I remove this, then here probably there will be a violation here. But let me just change this cell to something else and show you an example. So ultimately, you should understand that what you should check for when you are fixing setup, what you should check for when you are fixing hold. So as an example, what I'll do, I'll just size this, I'll resize this. Now a delay cell, so this command size cell, I give the instances and I give the new cell type. Now usually delay cells and buffers, size cell only works between the same function. So a buffer and a delay cell will only be compatible if they have same function. Usually they have same function. You cannot size a buffer into an inverter, right? So let's try this command which was suggested in the slide. Get alternate lib cells minus help. Get alternate lib cells minus base names, and I will give, let's say, this delay cell. Okay, sorry, I will give this instance name. So it gave me a big list that all these cells are compatible. See, delay cell here DL is compatible with bus. So let me just for this experiment, I will size this just to show you the usage of the command. I will size this. I am sizing this to, let's say I am sizing it to bus BD. Now I have changed the netlist. I have to do update timing. It will do something, some timing calculation. And now I do again the report timing through the same cell. Now this cell is bus BD1 and see, I sized this to buffer and now it's violating hold, but it will solve the setup. It will solve the setup. So this is how you use the size cell attribute, but I have sized a particular cell which I shouldn't have done, but I hope you will be more careful when you do timing analysis yourself. Right? This was the example of size cell. This is how you do what if analysis. Let's try and solve this hold violation now. We have created a hold violation. Now let's try and solve it. Now what I could do is I know that this if I add, so what I'll do is, so here the problem is something. So here there's some problem in the sense that now I see it is the fan out here is 5. Now what I will do, the hold violation is here. I want to see the setup slack here first. There is a 110 ps hold. There's a 110 ps minus 0.11 is the slack here. I want, before fixing this, so the first priority is to fix at the endpoint. Before fixing at the endpoint, I will see what is the setup slack. Again, setup slack you should always see in the worst corner. We are already working in the worst corner. This hold violation will be more. The WS should be more in the best corner. Let's do a report timing minus to this particular endpoint because I am planning to add delay here. So there's a lot of slack here. At least this session is concerned. There's a lot of slack. So I'll add a buffer here. How do I add a buffer? I say insert buffer. I'll do minus help. So this buffer has a delay of 0.15, and the violation here. See, now the delay here is 0.15 to setup report, but the delay is 0.12 for the whole report because of the delay. Same cell, setup report it will show more delay, whole report it will show less delay. So whenever you are trying to identify which cells to add or which cells to swap, you should take into account the margins. So let's say I want to add X amount of delay. So if I add X amount of delay, if I am able to add X amount of delay for the nominal case, the delay in the setup report will become 1.1x if the delay is 1.1 for late. It will become 0.9x if the delay is for whole path, if the delay is 0.9. So usually you will have to take some margins into consideration. There are so many things like that which we can discuss, but again this will come from experience. But you should first and foremost you should know that runtime supports this kind of what if analysis, what are the commands, and what are the basic set of rules that you should keep in mind. And rest will come with experience, with hands-on experience. So let me add one more buffer here. It gives 0.12 delay in hold, so it will probably solve this violation. I want to add the buffer here at this point, so I do insert buffer minus L. So I insert buffer. You can also add an inverter pair. So you can give new net name, new cell name, but if you don't give it, will assign a some default name. But so let me just I will buffer this particular pin. I see that pin or port list is an option here. I give this pin, and I will give what lib cell, what buffer to use. I will use the same buffer. So it inserted a buffer U1. At this, it named the buffer U1. That's why it's a good idea to add some kind of a prefix or suffix after in the name to make sure that you can identify this buffer easily. This type of UPI easily. Which is from this library, it picks this buffer, right? And now let's do update timing. And now I will do a report timing delay min. I will do report timing to this minus delay min to see if the whole violation is solved. Yes, the whole violation is solved, but this is where you have to be careful. It is not giving ampersand, this is giving H, means it is a hybrid timing calculation. Because we added a new buffer, a new net was created. There are no parasitics for this new net. The parasitics can only come. Please focus on this. Please listen carefully on this statement. Any such ECO, any such what if analysis we do is not legalized yet. What it means is that the real ECO will be implemented when this change goes to the backend netlist. In case of side cell, it was comparatively better because okay, yes, the drive strength has increased or decreased, but the net, there is no new net created. Although there might be some displacement when it goes to the backend too. But in case of insert buffer, a new net is created. I will give minus nets and we will see what is the new net. This is a new net that is created. There is no parasitic for this. So for the input of this cell, what prime time will do, it will use the earlier net. So for example, this net here, whatever net was driving this buffer earlier, this pin earlier, prime time will use it to drive now the new buffer, and it will add do timing calculation here, which it tells is hybrid timing calculation. That means it is using whatever was the earlier net, plus it is probably using a while load model or a zero delay model. So that therefore it tells us that it is H. It is not ampersand. It is not stress. Everything is not coming from stress. Some part is coming from stress. Some part is coming from while load model. So this is not yet legalized. It is shown me that flag is met, yes, but it has to go to backend. So all such what if analysis you do, you can write out in an ECO file from prime time. In that ECO file, you can give it to the backend engineer and get the ECO implemented, legalized, right? So this was the, so we could see again the setup slack through this minus through this particular cell that we have added, and yeah, that's okay. We can we have added this particular cell. We'll do this. So fine, setup slack is also fine. Now here, since we added the cell at the endpoint, directly at the endpoint, timing endpoint, there will not be any through paths. I mean, there's only one path, unique path. It will not affect any other path. It will only affect this particular path, right? So this was all about what if analysis. Again, I would request you to get hands-on experience from time to time before attempting this unit. This unit will make most sense when you have had some experience with time. Now I'll give some examples of attributes. Now let's do a report attribute on some objects. So as I told you, the objects are cells, nets, ports, pins, and so on. So let me choose a particular cell and report some attribute. Let's say I report attribute on. So report attribute has this thing. So you can give class also. Class is not compulsory. If it cannot detect what is the class of the object, it will ask you to give class. Minus application means what all attributes are defined via .lib or via application. So you should always give minus application to see all the useful attributes. I do a get cells. Let's say I do what is on this particular memory. Now it is listing all these attributes for this particular memory. So it tells us that design is Orca, object is this particular cell. Obviously, in this complete report, the object is cell. The type of the attribute is float. Here, the attribute name is area. So this is the area of. Area is an attribute on this cell, and the value is this. Again, the attribute is base name. The value is PCI W34M. This is the base name. Base name means the name of the instance without the hierarchy, right? There will be something called, it has disabled timing. The type is Boolean. It can either be true or false. Disabled timing is true. I'm not sure some timing might be disabled here. Don't touch is true. Don't touch is true means now prime time will or synthesis can use these attributes. Early is false, cell check, derate factor. Early, false, clock, cell check. These are the derates. Whatever we have given. These are check derates. We haven't given any check derate. So check derate are all 1. Cell derate is 0.9 for early, and late derate will come later. Full name. This full name is a full instance name. Is black box true? Yes, because prime time does not have functionality, and so on. So these are the complete list of attributes that is available for you to play with. Let's do some attributes on some net. Let's do a report timing first. Let's do report attribute minus application on some net. Let's say I give report timing, okay, and I'll do now report timing. Report attribute minus application get net. I'll give, let's say, this particular net. Minus no split will not split the line. So these are so many attributes on this net. Capacitances and so on. Capacitances, names, has detailed parasitic. So the has detailed parasitic, for example, if you want to write your own procedure to check whether all the nets have parasitics, you can use such kind of attributes. You can check whether you can get a collection of all the nets, and for each net check whether each net has detailed parasitics and has valid parasitics, and so on. This is now I'll write a small snippet of code, and I will show you how we can use this attribute. Use these attributes. First, I will use. Let's give an example of get attribute command. Now let's say I want. Let's do a report timing first to get some data. Group PCLK minus split. Yeah. Now let's say I want to find out the area for this particular cell. Now I am just giving some examples. They may be useful or they may be weird, but at least they will show you the usage of get attribute and how to use attribute. Let's say I want to know the area of this cell. So I know that area is an attribute. I say get attribute. Get attribute. Get attribute. You give first what is the object name. I say get cells. This is the object, and I know that the attribute name is area. So this is the area of this cell. I want to know what all pins are there. Let's say I want to know the number of pins of this particular cell. I think the number of pins is an attribute. Let me do a so to know what all attributes are there, you can do report attributes and application of it. This will give you a detail factor. This will give you a detailed thing. So number of pins. It's number of pins. So if you do a get attribute on this number of pins, then it will give you the number of pins here. Right. So now let's give you an example of a slightly more elaborate code. Let's say again I'll do a report timing. Now we saw that there is a delay cell here. This is now a different path. This is not a delay cell that we size upsize. This is a different. Now let's say I want to know. I see that okay, this delay cell is given so much delay. Now let's say I want to find out a list of all the cells that are of this particular type, that are of the type DL type, and of any drive string. They can be of any drive string, and I want to find out where they are. What is the complete list? So let me write out a code. What I do, the idea is first we have to get. I'll build the code. I'll mimic the way that you will probably think and start building the code. First, I need a list of cells of this particular type. How do I do that? I know that if I do get cells, I do get attribute on this particular cell. Let's say I'll use this as an example. I will use this particular cell, and if I do a ref name, I know that it will give me the ref name. Now I have to build a collection of all such cells which with these ref names. So there are two commands you can use. You can use a filter collection, or you can use minus filter option in the get cells. So I'll use the minus filter option. Get cells minus hierarchical is when you want to go through the complete hierarchy. Now I want all cells for which the ref name is, let's say DL102D1. I say minus filter, and here I can give ref name. This is how you can use the minus filter option of get cells or get nets or anything with the get. You can use this particular filter attribute. This filter, it has a minus option filter, so you can check minus help first whether it has a filter option. So ref name is equal to this info. This will give me a list of all the cells, a collection. In fact, it will return a collection. Collection is an array in Pickle. It will return a collection with all the cells with the same ref name. So this is the collection. Now, if I want to know the number, I can do a size of collection. So 16. There are 16 delay cells of this particular nature, but I haven't still got the list where I get delay cells of all the drive string. I don't want just D1. I want all the drive string. Another thing, this get cells returns a collection. So if you try to do something like this, then it will give something underscore cell something. This is just a pointer. So this get cells is not printable. This is not a string. It is a collection. If you want to echo it something like this, you can do a query object. So what I could do, I can store this collection in, let's say, my collection, and I can do something like this. So my collection is, but if later I want to see what is my collection, and if I do echo, then it will not tell me anything. It will just give me some pointer. You can use a query objects to query objects to print the value. So this will print the value. Now what I will do is, I now don't want the single drive step, I want multiple drive steps. So I can do something like this. Star, enclose it within double quotes, and use a similarity operator. So if the ref name, I know that drive strength is the last digit. So any delay cell, delay 102 whatever, D star, it will give me. So probably the list is same. Is it same? Is it more? I think it is more. So I'll do a size of collection to see if there are. Now there are 17. So there's one more of another drive strength. Now here I want not even of different drive strength. I want all DL cells. So usually DL cells are depicted by two things. One is the what delay they provide. So probably 02 is the measure of the delay, and D X star is the drive strength. So I can do DL star, and let me see this. Okay, 17. So these are the total delay cells. So now I'll store this I'll again store this in one of the collection just to make things easier later. So now I have a list of some objects. I have arranged a collection based on some filtering criteria, and remember I used the attribute. This is the attribute. Ref name is the attribute. That is why I could use the filter option of get cells. Now I want to, let's say, print it, and I also want to know now. So see, there are different kind of drive strings there, and there can be different type of delay cells. This collection represents different types of delay cells with different drive strings, right? But that was a problem specification. Now I want to print the instance name, and I want to print the reference name. I want to see what type of delay cell it is. What is the drive string of this? So I'll use a for each in collection. I have a collection already. This for each in collection is a for loop that runs on a collection. I give any variable here, anything, let's say xy. I have already made a collection called my call. It will run through my call as you write a procedure and enclose it within curly braces. Now I have to say echo get attribute $xy is the iteration variable, and I want the full name attribute. Again, I want to know what is the reference name of each of these cells. So this is a procedure. It will give me it will run through this particular collection. This is iteration. This is the loop variable xy, and I want the full name. This is the full name. This is the reference name. This is the cell type. So we see that there is a D2 type, there is a D1 type. Now let's say somebody asks me that what is the area? What is the area impact of adding all these delay cells? Okay, yes, boss, we have added so many delay cells to solve time innovation. But what is the area increase? What is the so you can do something like this. Again, we will run through each of these collections, and I will calculate the area by using get attribute of what I'll do first. I'll do nothing. I'll set let's say DL underscore area to be 0. Now what I'll do is I'll do for each collection. I'll do xy. I'll do $my call. Then I will do. I will set the area to be set a variable get attribute $xy and area. So this will store the area value in A, and then I will set DL area, and so the command to the simple plus and minus will won't go directly. You have to call a function called expr to do all kind of mathematical operations. So in the DL area itself, I will add the value of A, So this will sum up all the area, and I can echo the DL area, and it will give me the complete area. So this is the complete area for each of the combining all the delay cells together. This is the area impact of adding all these delay cells together. So this is the way you can do lot of things, infinitely many things. You can use lot of attributes, and so this was about the object. Now one of the most interesting object is a timing path. So timing path is a special kind of object. So what you could do, let's say you want something like you want to check the slack on a particular memory's address pins. Now let's do a report timing minus. This is the last example that I discussed. Obviously these examples are not exhaustive. They are just to show you that what can be accomplished in prime time using attributes and using tickle commands, so that you know this will act as a starting point for you. This is a good starting point for you to start exploring the applications of attributes in time time. So let's do a delay min and let's do a group on PCL. So we saw memory. This is a memory. Now I want to know what is the slack on. So this is the address pin of the memory. I want to know first. Let me see what all are the address pins of this. How many are the address pins of this memory? So usually in this case I know that address pins will start with A. So I do A star. So there are so many address pins. Now let's say somebody asks you, get me the slack value, the whole slack value of all the memory pins. So I'll do a size of collection to see how many pins are there. Now I want to report the slack of all the memory pins. How do you do that? An amateur guy will write out the report timing report for all the memory pins, and he will grep, either use the grep command or do it manually, note down the slack of each memory pin separately and then show it to the guy who is asking for it. But as an experienced ST engineer, what you could do, you can make use of attributes. There is a very interesting attribute called get timing path. The report timing reports the text value. Get timing path will give you a collection of object of timing path. So what I'll do, almost all the attributes, almost all the options in report timing are supported in get timing path. So what I'll do is I'll do something like, so if you want to report timing, so the first thing, what would you do if you want to report timing? So if I want to report timing on these memory pins, I'll do report timing minus delay min minus to all these pins. Let's say I'll do path type summary. I'll do minus no space. So it will give me only two. It is giving me only two endpoints because they might be on different, A1 and A2 are on different clock domains. Now I know I have to increase the max path because there are about 20 pins, so I do it 20. So it will give me. So it is giving me the whole timing for. Okay, there are 10 invalid endpoints for constrained paths. It means that 10 of the paths are not constrained; they are unconstrained. Out of 20, 10 are constrained. Now let's say I want to know the slack on each of these. I will set a time collection. I will set a collection. Tim's underscore COL is any collection if you have any name, and I will use the same options, get timing paths, and I'll give the same options. The only thing that will change is the part type, because part type and no split are more for reporting. So this is not a reporting. This is making the collection. So I'll do something like this, and now I get a new collection which contains now. If I do query object on this, it would be interesting. So it says it cannot be queried because it's a collection of timing paths. It has, so report timing showed me 10 paths, and it says that 10 are unconstrained. It's okay. These 10 are contained in this. This whole information about this are contained in this. So what I could do is that let's do a particular interesting. I can do a get. So let me show you how it happens on a single path. So if I don't do a max path here, it will report a single path. and it will not report anything. It will just say that it will form a selection. Now I can do a get attribute on so now it is reporting the slack values just like this -0.22. This is the significant digit 2. This is the significant digit 6. Similarly, I form the collection here. This is the collection that I formed. Now what I can do for each in collection using $CM_COL, and now remember this particular collection has 20 paths or 10 paths, 10 constraint paths, and then I will echo get attribute $xy. The attribute, so timing path has a lot of attributes. One of them is flat. Again, I get attribute. Let's say get attribute. I think it's end point mean. I'm guessing. I need to double check. Oh, sorry. Okay, endpoint is not defined, but see here it gives me the slack value. So I'll just this is the so for all such 10 timing paths, it is recording the slack value. So this is how you play with get timing collection, get timing paths. Similar to the objects like cells, nets, a timing path is a much more powerful object. So what I can do, I can say report attributes minus application on, let's say, get timing path. I can do anything. I can say get timing path minus group, let's say PCLK minus delay min. This will give me the worst path in PCLK. I report attribute. So these are all the attributes that are defined on this particular timing path. You can actually build your own report timing command if you want. It tells us what is the arrival. Capture clock paths is a collection. So this type can be collection now. Endpoint clock, string, and so on. These are so many endpoint clock is inverted. It gives you so many options here. It gives so many attributes. So you can use this. So required time. See, it has required time. It has slack. It has arrival time. You can check what is the arrival time here. You can report what is the arrival time here. For example, you can report arrival time here. Arrival time has not been defined for this timing path. Okay, I'm not sure why arrival. Okay, it's only arrival. Okay, so these are arrivals. So you can do so many infinite number of things with get timing path on timing path. So otherwise, all the other object classes, cell, net, port, pin, will help you get the values such as area, the cell type, the capacitance, and all that. Get timing path, on the other hand, will give you complete data with respect to any timing path you want. So get timing path is in fact the command that is mostly used in scripts that do automatic kind of fixing, that suggest that do automatic timing issues, because they work on the report, they work on the timing paths, and instead of writing out the report timing into a report file and doing text, doing some text-based operation on those, it is more difficult when compared to get timing path, extracting data from the get timing path using attributes. So this was all about prime time. This is the end of unit 5, and I hope you enjoyed it. I hope you learned a lot of stuff, a lot of new stuff. So again, this particular session, please get yourself a lot of practice on prime time before attempting the attributes and what if analysis. Attributes are very, very interesting. You can do a lot of things with it. You can make very nifty scripts to do stuff quickly in your job, in your projects. So all the best with that. Thank you.